So welcome to Science Intellect Hub. My name is Mr. Mujaki Sanese. They call me Mr. M. Mfanabo. So, halala, right now. Well, we are going to talk about energy and change. Apparently, matter does not stay the same. Over time, matter will undergo change. And the change that matter can undergo could be a physical change or a chemical change. So whether we are having a physical change or a chemical change, it matters not. One thing for sure is that energy is going to be involved somehow. Think about when you boil water to make that hot cup of tea. Energy needs to be involved somewhere. But now, we have to ask ourselves as to what exactly are we talking of and about when we talk about energy in this context? Well, heat and energy will mean the same shit in this context. So, halala, right now. So, a physical change is a change that can be seen. It's a change that can be felt. A physical change, of course, does not involve any chemical breakup of particles. Maybe we can change the state of matter, but not the chemical composition of that particular substance. If it was water, it will remain water. But the only difference is that we will now be having water as solid, or we'll be having water as liquid, or we'll be having water as gas. The chemical composition of the substance will still be the same at that particular time and moment in front of us. So, halala, right now. Well, I want us to be aware also that a physical change is easily reversible compared to a chemical change. I can move from a solid to a liquid. I can move from a liquid to a gas. But I can also move from a gas to a liquid to a gas. That means, or rather a liquid to a solid. So that means that my reaction thereof is reversible. What we have in front of us here, we will consider it as being the system. The system will be whatever we are considering in this context then. So the solid ice or the liquid water or the steam gas there will be our system of consideration. But because we are talking about energy and change, we will be interested then in what will energy do to the system thereof. That is what we want to be able to look at here. The relationship between the energy of the environment and the energy of the system. So since I have the system there, I should also have the environment outside, or what we call the surroundings. So there should be an interchange of energy between the environment and the system, and vice versa. It's a necessity mfanabo. So halala, right now. So in order for me to move from a solid ice to a liquid gas, or rather to a liquid water, from liquid water to steam gas, there should be something that is happening to the energy. It means the solid ice, take for instance, when you put a cube of ice in a pot of water, or rather in a pot, of course what is going to happen? You're going to light the stove. As you light the stove, what is going to happen? The solid ice is going to do what? Is going to absorb energy from the heat. Remember that heat is provided by the environment. So halala, right now, the heat is provided by the environment. So what is going to happen is that the environment is going to provide heat to the system. That is what is happening. Heat from the environment is going to be provided to the system, meaning the system is doing what? The system is absorbing energy. That is what is happening here. The system is absorbing heat. It is absorbing energy. That is what is happening here. Mfanabo. So, halala, right now. So also, in order for me, of course, to move from a liquid to a gas, I should also absorb energy from the environment to the system. That is what we are talking of and about. But now, because we are considering a physical change, therefore the process involving absorbing of energy, absorbing of heat, will be referred to as an endothermic process. So we refer to this then as being an endothermic process. Halala, right now. Well, remember that we've said physical changes are usually reversible. So it means instead of me moving from a solid to a liquid, from a liquid to a gas, instead I could do the opposite and move from a gas to a liquid, and we call that condensation. And also, of course, I can move from liquid to a solid. That is freezing, of course. But also here, you also have to ask yourself as to what is happening to the energy changes between the environment and the system. Remember, steam has a lot of energy. So what it does is that it releases the energy so that it becomes cold, and when it becomes cold, it becomes liquid. So it is releasing its energy. That is what is happening here. In actual fact, let me change color here. So it is releasing energy. That is what it does. It is releasing energy from the system to the environment. That's what we say here. So also the liquid, for it to move from the liquid phase to the solid ice, it has to release the least of energy that it has. It releases it from the system to the environment. So what is important here is that energy has been released. So for such processes then, because we are talking about a physical change, we refer to them as exothermic processes. So halala, right now. Well, so far we've only looked at physical change, and we've recognized that when a physical change happens to matter, it could be an endothermic process, or it could be an exothermic process. Now we want to consider chemical change. Remember, chemical change, chemical reaction, same shit in front of us. So halala, right now. So do you remember that in our discussion of a physical change, we've said that we have a system and we have the environment or the surroundings? Well, also with chemical change, we will be looking at the relationship between energy of the system and energy of the environment. That is what we are going to be looking at. So halala, right now. So obviously when we write a chemical equation, we start with reactants, we show that arrow, then we show the products. That's what is happening here. So for this chemical reaction to even happen, remember with chemical change, we are talking about a chemical breakup of particles. Here we break particles, here we break atoms. So that is what is happening here. And as we do so, there's going to be energy changes involved thereof. So what we know then in a chemical equation is that we will have to do what? we will have to break the reactants. That's what we have to do. We have to break the reactants in order to do what? In order to form them products mfanabo. So halala right now. So we will need that energy somewhere somehow in order to do what? In order to break the reactants, and that energy is called bond energy. Bazo zanga exam mfanabo. So njalo nje. So it is called bond energy. So bond energy is the energy required to break two atoms here mfanabo. So it means we will need energy somewhere somehow. From where? From the system to where? To the environment. Or rather the other way around. From where? From the environment to where? To the system. That is what is going to happen here. We are absorbing energy. If you are aware here, we are absorbing energy. I don't know if that is the correct spelling of absorb. Absolutely not. It's incorrect. But you know the correct one. So what we are doing here, we are absorbing energy from the environment to the system in order to do what? In order to break these atoms in the reactants. So now that we have absorbed energy from the environment to the system in order to break the atoms, of course we will form products. And as we form products, in actual fact, then we will what? Then we will release energy. That is what is going to happen here. We will release energy. So you can see also with a chemical change, we have to be interested in the absorption and releasing of energy. And we said that involves endothermic and exothermic processes in the case of physical change. But in the case of chemical change, we are going to talk about an exothermic reaction. We are going to talk about an endothermic reaction. But what I want to make clear at this time and moment is that whether we are talking about an exothermic or an endothermic reaction, there is energy absorbed somehow, as you've seen. Whether we are talking about endothermic reaction or exothermic reaction, there will be some energy absorbed and there will also be some energy released. But depending on how much is absorbed or how much is released, then that's when we can be able to make conclusions as to whether we are talking about an exothermic reaction or an endothermic reaction. So halala right now. Well, now when we look back, we can be able to see that in actual fact, when a chemical change happens, when a chemical reaction happens, it could either be an exothermic reaction or it could be an endothermic reaction. So now, depending on whether overall energy has been released or absorbed, that's when now we can come to a conclusion that which one is which. So overall, for an exothermic reaction, energy is released. Check. That is what we say. So it means then processes or rather reactions whereby energy is released are referred to as exothermic reactions. However, on the latter, when you talk about an endothermic reaction, it is a reaction whereby energy is absorbed. That is what we say. Check. Now, remember we are doing chemical change. In actual fact, our interest is more on chemical change than it is on physical change. Therefore, we should be able to represent chemical change through, of course, understanding that when we write an equation, we write reactants, we show the arrow, products. But for the case of exothermic reaction, we say plus energy. That plus energy is to imply that energy has been released overall. The system releases the energy to the environment. That's an exothermic reaction. But of course, you can see the difference then in terms of how we represent chemical change for an exothermic reaction versus an endothermic reaction. For an endothermic reaction, we will have reactants plus energy. That plus energy in the reactants is to imply that we have to absorb more energy than we release. So we have to absorb energy. Since we absorb energy, then that is an endothermic reaction, and overall we'll have the products then. So now the other concept that I'll be very much interested in, of course, is the concept of enthalpy or heat of reaction. In actual fact, we represent this using delta H. So here they say for an exothermic reaction, delta H is negative, it is less than 0. Here they say delta H, which is the heat of reaction, which is the enthalpy. For what? For an endothermic reaction, it is positive, it is greater than 0. Well, how then do we calculate heat of reaction? Well, we calculate heat of reaction by saying the energy of the product minus the energy of the reactants. Remember, I said heat and energy, same shit, by the way. So, well, this concept of heat of reaction, we will understand it in the next lesson when we talk about energy profiles of an exothermic reaction and an endothermic reaction. That is where you will have a clearer understanding of what we mean by heat of reaction. For now, that is just, of course, just about how much I have for you. So I hope you found value in this video, and if you did, take 1 second, go down there, hit that subscribe button. I'm waiting for you. Go on, I'm waiting for you. I'm still waiting. It is free. Hit that subscribe button, and of course, like the video if you found value. Until we meet on the next video, whereby we'll be discussing exothermic and endothermic reactions. Most importantly, the energy profiles of these, and also a clearer understanding of heat of reaction or enthalpy. Welcome to Science Intellect Hub. My name is Mr. Mojakisane, sir. They call me Mr. Mfana So, halala right now till we meet again. Peace.